This is lecture 10.3 for Psych 440, Utility. So in this lecture, we're going to start out by defining the ideas of decision accuracy and utility. Both of these are concerned with what's the practical impact of a selection system? What's the organization going to get for going to all of this time and effort and expense? Along the way, we're going to have to explain a couple of concepts called the base rate and the selection ratio. These both influence the amount of utility we can get from a particular test. They set some limits, some constraints on how much use a selection system will be to us. We're going to talk about the decision accuracy approach that's described in your textbook, but I also want to introduce a couple of other ways we can approach estimating utility. So we'll talk about two systems called the Taylor-Russell tables and the Losch tables, which are very well-established, kind of traditional methods of establishing utility. And then I want to introduce you to a really fun thing called the Brogden-Cronbach-Glaser utility formula, which goes one step beyond all of the rest of these and actually helps us put a dollar estimate on the value of a selection system. So how is a selection system going to translate into improved financial outcomes for the organization? So this lecture is very focused on practical tools that industrial and organizational psychologists use all the time to try and evaluate how well are we doing? How much are we helping by creating this new selection system? Right. So your textbook starts with one of the oldest, the best established methods of looking at utility, and it's a framework that we call decision accuracy. As you might guess from the name, what decision accuracy tells us is how often are we going to be right in our decisions to hire or not to hire a particular job applicant. So we start out, just like we've been doing in talking about validity coefficients, we plot our employees or our applicants' test scores down here against their actual job performance. So you know we either need a really well done predictive validity study where we don't have restriction of range, or we have a concurrent validity study. Here we've got what looks like a pretty decent selection test. We've got a nice positive relationship here. People who score higher on the test tend to be better job performers. For the decision accuracy framework, though, we have to go through and figure out what are acceptable minimums for each of these variables. So we have to figure out what's an acceptable level of performance. If you want to think about this in concrete terms, maybe performance here is the number of high-quality widgets made in a week. So we want to make sure that we want employees to make at least about 55 widgets a week. Below that, we would say they're not acceptable job performers. We're also going to set, or propose at least, a cut score on the test. We would say anybody who scores above a 50, we would recommend for hire. Anyone who scores below this score, we think probably we're going to recommend that they not be hired. When we've set both of these minimums, we can divide this graph up into 4 quadrants. Each of these 4 quadrants represents a different kind of a decision that we've made. Up here in quadrant 2, we're going to call these people successes. These are people that we recommended to be hired on the basis of their test score, and they did turn out to be at least acceptable employees. So these are people that we were right to recommend hiring. Down here in quadrant 4, only one out there. In fact, there have been a number of methods developed over the years for evaluating the utility of selection methods. This is important because you've probably gotten the sense over the last couple of modules, selection systems are complicated. They can be very expensive, they can be very time-consuming to develop. And if you think about the perspective of a vice president of HR in an organization, they're probably saying, well, yes, okay, that's the right way to do it, but how do I know it's worth it? How do I know this is worth this large investment? Well, one of the things we know from utility analysis is it's not always worth the investment. If all of your current employees that you've hired under whatever your existing selection system is, if they're all doing great, then a new selection system is probably not going to change things for you very much. If what you've got is working, if it's not getting you into legal trouble, you might as well stick with it. There's also not much benefit to having a really good selection system if you're not in a position to be choosy. If you really do have a terrible turnover problem or a great big labor force shortage, and you pretty much do have to hire everyone who walks in to apply for the job, then the greatest selection system in the world isn't going to do you a whole lot of good. However, when either of these things, or when both of these things are not true, if you think it's possible what is the base rate? The base rate is the percentage of current employees that are considered successful on the job right now. I said a minute ago, if your base rate is 100%, then you probably don't need a new selection system. We're only going to worry about selection when our base rate is something probably substantially less than 100%. The base rate is really useful for comparing selection systems. It doesn't do much good to compare the base rate of your selection system to the base rate if you just hired employees by flipping a coin, because nobody flips a coin. But we can directly compare one selection system head-to-head against another one this way. How do we set the base rate? Well, this is one of those situations where it's very much a judgment call. It's typically based on the organization's criteria, their views of what's a successful employee or what's an unsuccessful employee. When we talked about acceptable performance a minute ago, if we said the organization thinks that making 55 widgets a week is acceptable performance and anything less than that is unacceptable, that's their decision to make. Ideally, we can link this to good, well-developed performance criteria. We can have some kind of a rational basis for this, but it's not usually a number we can easily calculate from objective data. We need the organization's input to say, well, how good do you think your employees are? Next critical number that we need to evaluate utility is the selection ratio. As you might guess from the name, this is out of the total number of people who apply for the job, what proportion of them are you going to select? So a smaller selection ratio means that you're being pickier. A selection ratio of 0.10 is a selection rate of 10%. You're hiring 1 in 10 applicants. That's a lot pickier than if you have a selection ratio of 0.8, which would mean you're hiring 80% or 8 out of every 10 applicants. Now, the smaller your selection ratio, the bigger difference having a good selection system will make. If you have to hire everybody again, the best selection system in the world doesn't do you much good. But when you're in a position to be choosy, having the power to choose really well is very, very helpful. And we can see some practical examples of that in just a minute. The third major parameter we have to consider here is the cost of the selection system. If you think about in a lecture about combining predictors, think about a multiple hurdles approach where you might do resume screens, you might have a cognitive ability test, a personality test, some interviews, an assessment center. There's a lot of pieces to that puzzle. It's time consuming, it's expensive to evaluate even just a small number of applicants. So if we're going to develop a new selection system, we need to have some reason to be confident that whatever increase we expect in revenue from having better employees is going to offset the cost of developing that selection system. Now, if you think this is a hard case to make, I'd like you just to pause and consider for a minute that there are organizations, the FBI, NASA are among them, that have been known to spend millions of dollars developing a selection system. Take just a second and jot down some notes about why you think that might be the case. Well, as with most things, there are multiple reasons that play into that decision, but probably the biggest is that those are very high-stakes organizations where the cost of failure is very great. If you hire the wrong astronaut, if you make a poor choice about an FBI agent, you can have potentially a very, very, very expensive failure on your hands. You can have a large national scandal. You may have expensive settlements to pay out. So the cost of selecting the wrong employee is great enough that some organizations find it absolutely worth their while to spend millions up front to avoid that mistake. So the cost of selection systems can be daunting, but it's a lot less daunting when you can weigh it against a good estimate of probable revenue or probable future cost savings that the organization might incur if they select the right employees instead of the wrong ones down the road. Now, so our three key parameters here, in addition to the validity of the test, are the selection ratio, the base rate, and the cost. I want to talk about three different ways we can combine these parameters to get some different pieces of information about the utility of our selection system. First of these is called the Taylor-Russell tables, developed, as you might expect, by a couple of researchers named Taylor and Russell in about the 1970s. They were concerned with helping an organization figure out what proportion of your new hires are going to be successful. That is, we know your current base rate. If you use this test instead or this selection system instead, this is the base rate you can expect to have in the future. So it combines those three pieces of information, the validity coefficient, the selection ratio, and the base rate. And what they did is they created a large set of tables where you can plug in various values for each of these factors and get an estimate of what your new base rate would look like. So here's an example of part of the Taylor-Russell tables. We combine the selection ratio, the base rate of success, and the validity coefficient of our selection system. And then these numbers in here, they give us an estimate of the new base rate. So imagine that we have a situation where only about half of our current employees are satisfactory. This is not a great state of affairs. We're pretty motivated to go out and improve our base rate. We want to have a new selection system. So our base rate right here is 0.5. Let's say that It's a pretty good labor market. We get lots of applicants. We can afford to be picky. We're going to select the top 10%. And we're looking at a new selection system that we've estimated has a validity coefficient of 0.25. Now remember, when we talked about the size of validity coefficients, 0.25 doesn't sound all that great. It's not a very large, it's not a very impressive correlation, but it is a fairly typical correlation for things like personality predictors of performance. So let's say we're considering implementing a new personality test. We know our three pieces. We plug in, we say for our base rate, our selection ratio of 0.10, our validity coefficient of 0.25, our new base rate, according to the Taylor-Russell tables, should be about 67%. So we've gone from having half our employees being satisfactory to 2/3 of our employees being satisfactory. Now, we'd love to see that number higher, but it's definitely an improvement. And now as an organization, we can make a decision, is it worth the cost of that selection system to have 2/3 of our employees be satisfactory compared to just half? So the Taylor-Russell tables work really well if we're concerned with overall the group of new employees that we're going to hire. The Losch tables were developed to answer a slightly different question. The Losch tables were designed for the situation in which you're interviewing, testing applicants one at a time. You don't have time to wait to see the group overall, but you want to get an estimate of how likely is it that a particular job applicant is going to end up being successful. Again, we're going to need the validity coefficient of the test and the base rate, but instead of the selection ratio, because now we're just looking at one person, we're going to look at the applicant's test score. And the Losch tables are designed to be easy to read, so they just break test scores down and say, are you in the top 20%, the next 20%, the middle 20%, or so on. The Losch tables look like this. Pretty similar to the Taylor-Russell tables, but with some different parameters. Over here, we've got the base rate. Here we've got the validity coefficient. Here we've got those quintiles. Where did the applicant score on the selection test? So, say we have that same scenario. We've got a 50% base rate right here. Our test now has a predictive validity coefficient of 0.3 right there. If we have an applicant who comes in scoring in the top 20%, that person has a 67% chance to be successful. If they were an applicant who's scoring in the middle 20%, only has about a 50-50 chance of being successful. But if somebody comes and scores down here in the bottom 20%, we know they've only got a 1 in 3 chance of being successful. And so we can weight those odds as we decide whether or not to hire that applicant. So there's our 67% chance of success in here. Now the odds of success in the Losch tables are going to get better as our validity coefficient increases. Note how all the numbers get bigger as we go farther down. As our base rate gets bigger, all the numbers in each section get bigger. And as test scores get better, our odds of success increase. So down here, if most employees are pretty good, we've got a test with fantastic predictive validity, and we've got a top scoring applicant, that person is very, very likely to be successful. So it's not just the validity coefficient that makes the difference here. We've got to take into account the base rate as well. Now, one last approach to looking at utility. This one is just a tiny bit more complicated, but not much. It's called the Brogdon-Cronbach-Glaser utility formula. You're welcome to call it the BCG utility formula. This is going to take it one step further and put utility in financial terms. We need just a little bit more information for the BCG utility formula. we're going to pay attention to how many employees does the organization hire for this position in a year. On average, how long do they stay? So employees, hiring good employees who stay longer is going to result in better financial outcomes for the organization than good employees who only stay for a few months. We need the validity coefficient again. We need something called the standard deviation of performance in dollars. Now you could imagine in a sales job, you could estimate this pretty directly. You could say, what's the average sales for people with this job title? All right, what's one standard deviation of that? Very often we don't have that immediate data, so we might estimate this. We might ask our organization, what do you think is the financial impact of having an above average employee, somebody who's a standard deviation above the mean, compared to one who's just average? They might be able to make a good educated guess there. If they can't, there's some data that suggests that about 40% of the average salary for a position ends up being a pretty good estimate of the standard deviation of performance in dollars. So this is a hard number to get a perfect estimate of, but we can get some rough estimates that work pretty well. And then finally, we need the mean standardized test score. That just means the z-score, not necessarily that it's a standardized test, of the applicants that we're going to hire. So what this tells us is how far above the mean are the people that we're going to end up hiring. And this is kind of a rough proxy for the selection ratio. It's a measure of how picky we get to be. If we're hiring applicants who are 1.5 standard deviations above the mean, that means we're probably getting to be pretty picky. If we're going to end up hiring applicants who are half a standard deviation below the mean, that means we're probably hiring most people and we're not being very particular. So we need these 5 pieces of information plus the cost of the selection system. Again, we might have to settle for some estimates in here, but we can usually get at least good educated guesses. When we get these educated guesses, then the formula itself is not that bad. We take those 5 pieces and we multiply them all together. What this means is, as any one of these things gets bigger, the utility of our test gets better. So the more people we hire, the more utility we have. The longer they stay, the more utility. The more valid our test, the more utility. The more it makes a difference to have an above average employee compared to an average one, the more utility we get. And then the pickier we can be, the more utility we get. We're going to multiply those things together, and we're going to subtract the cost of testing. And here it's very important to factor in how many people are we testing. We also have to compute this not just for the selection system we're proposing, but since we want to show the organization that our new system is an improvement, we want to be able to compare. We want to estimate utility for both the current system and the one that we're proposing to replace it with. The difference between the utility for the current system and the utility for the proposed system is the dollar term benefit the organization could reasonably expect from implementing the new system. So let me show you how this works. I want you to imagine that we are working with a restaurant, a small local restaurant. Maybe they have a few locations, not a huge operation here. Probably not the type of organization that would be in a hurry to go develop a really good new selection system. In fact, what they're using right now is an unstructured interview. Somebody comes in, wants a job as a server. The general manager takes half an hour to give them an interview and decides whether or not to hire them. Right now, they're average. In a given year, they probably hire about 15 employees. They say, well, on average, most of our employees stay with us about 1.5 years. Well, we know from meta-analysis that the average predictive validity of an unstructured interview is about 0.11. It's not nothing, but it's not great. Right? So we can make a reasonable guess at the utility of their current system. Now we've got to ask, what's the difference between having an above average performer compared to an average performer? So we talk with the general managers. They say, well, our good servers, our above average servers, they bring in maybe another $100 a week in drink sales, dessert sales. They do make a little bit more money for us. So $100 a week is plausible. That's not a crazy out there number. So they say, yeah, that's probably pretty reasonable. If we multiply that by a year, we say it makes, having an above average employee makes a difference to the restaurant of about $5,200 over the course of a year. Right now, they say they've got lots of applicants, so they can afford to be a little picky. They can hire applicants who are a little above average, say not quite a whole standard deviation above the mean. Now, even an unstructured interview does have a small cost to the organization. They pay their restaurant managers $12 an hour. It takes half an hour for an interview. They interview about twice as many people as they hire, so you could say they're spending $6 of their general manager's time by 30 applicants a year. They're spending about $180 a year interviewing job applicants. That's a pretty low cost, pretty minimal selection system. There's not a huge financial difference in having a great performer versus a just barely okay performer. But we could estimate that there is some utility going on here. We multiply those first 5 pieces together. We subtract out the cost, and this organization is making an additional $10,000 a year compared to what they would be making if they just hired servers completely at random. So their current system, you might look at that and say, wow, that has some utility. That's not too bad. But we're going to propose that they could do a little bit better if they moved from an unstructured interview to a structured interview. So they're going to still hire the same number of employees. Their turnover rate's not going to change. We have a fairly conservative meta-analytic estimate that a decent structured interview has a predictive validity of about 0.34. Standard deviation of performance in dollars is the same. Average test score of selected applicants is going to be about the same, but it's going to be a little expensive to develop this interview. We're going to charge you $60 per applicant for 30 applicants a year. The selection system is going to cost you $1,800. Now, the typical small business owner is going to look at that price tag and say, that's a lot. I don't know that I want to spend that much money just on my hiring process. Let's see what happens when we plug the numbers into the utility formula. Just like before, we're going to multiply them all together. Now we've got before we subtract out the cost, utility of $31,000. We subtract out even that large cost. We're left with an overall revenue improvement of $30,000. Now we can't compare that against nothing. Their selection system before had some utility, but that's a $20,000 difference. And even a small mom and pop business, assuming they can come up with the upfront cost here, is likely to see some value in that. Spending $1,800 at a $20,000 return, most organizations are going to find that to be a worthwhile trade-off. So look over to the question on the right for a minute. See if you can recall what's the one factor that's different in this example. Hopefully you chose the validity coefficient. We could vary the other parameters in there, increasing our selectivity, increasing our number of employees selected in a year. All of those things are going to improve the potential utility of our selection system. So to kind of pull all of this together, each of these methods that we've talked about gives you different information about the utility of your test. The Taylor-Russell tables and the decision accuracy method, those are both going to tell you overall across a group of employees how many of them are likely to be successful under a particular selection method. The Losh tables are much more useful if you're concerned about evaluating applicants one at a time. Can you predict how likely it is that a single applicant will be successful? And finally, the BCG formula allows you to estimate that financial impact. Again, I'm going to say this one more time because it's really important. The key factors that tend to drive the utility of a test, first and foremost, the validity coefficient. If you don't have a good validity coefficient, you can't have much in the way of utility. But even when you have a good validity coefficient, you also have to take into account the base rate and the selection ratio. A low base rate and a low selection ratio give you space to have more utility. A high base rate means everybody's going to do fine whether you use a selection system or not. A high selection ratio means you have to select everybody whether they do well in the selection system or not. In those scenarios, you won't have much utility. But a high validity coefficient, a low base rate, and a low selection ratio give you the best combination for good utility. In our next lecture, we're going to just start introducing the key elements of federal anti-discrimination law, which is going to set up our next module covering discrimination and employment law in more detail.